the enthalpy of fusion, okay, so enthalpy of fusion, so that's HF of salt is 2.63 times 10 to the third joules per gram. Calculate the heat needed to measure 460 grams of sodium chloride. Okay, so now I am on, by the way, when doing heat curve problems, always a good idea to just start with a heat curve and figure out where you are. Okay, I'm given the enthalpy of fusion, and I'm melting, okay, which means that I'm going from a solid to a liquid. Okay, so here's my liquid phase, here's my solid phase, and there's no temperature change involved. So I've got from this point to this point. Okay, now some of you might be wondering what's going on in between these 2 points. Well, you'd have a mixture of solid and liquid. Okay, at this point it's all solid, at this point it's all liquid. Now if I move this way across, you are gaining energy from the surrounding. So the sign would be positive, okay? If you move this way, okay, you would be losing energy to the surrounding. So that would be like ice freezing, okay? So in order for that to be the case, the sign of heat would be negative. So sign is important through these transitions. You need to just kind of be aware of what's going on. So the sign going from here, we're melting, right? So we're going from solid to liquid, is going to be positive. So we just need to keep that in mind. And our heat is going to be the mass times the enthalpy of fusion. Okay, so that's 460 grams times 2.63 times 10 to the third joules per gram. Okay, notice I've taken my joules over grams and changed it into my preferred format. Okay, so now I'm going to get out my handy dandy calculator. Okay, now 460 grams, as it's written, has 2 sig figs. Okay, so my answer needs to have 2 sig figs. So I'm remembering that the sign of heat here needs to be positive, and it needs to be 1.2 times 10 to the 6th joules. Okay, so simple enough, right?